Today we're going to be solving Cambridge IGCSE Chemistry Paper 4 Theory Extended October-November 2025, Paper 42. The first question states, the three states of matter are solid, liquids and gases. Complete table 1.1 to describe the structures of solid, liquids and gases in terms of particle separation, particle arrangement and particle motion. So we gotta tell everything that we know. So in solids, they've told that the particles are touching each other. Now we have to tell the particle arrangement in solids. So we're gonna say that it's irregular because you know that in a solid lattice, what happens is that particles are regularly arranged, right? They're touching each other and they're in regular arrangement. And particle motion, you know that particles cannot basically move from their fixed positions, but they can just vibrate about fixed positions. So you can write vibrate about fixed positions, right? In liquid, what's the particle separation? Again, you know that in liquid, particles are touching each other, right? What's particle arrangement? It's random, right? And particle motion, how particles move, they can move randomly, they can move freely, they're not restricted, right? In liquids, particles can move freely. In gases, the particles are not touching each other, right? They're far apart. So separation is going to be they're far apart, while particle arrangement is going to be random and motion is also random. Substances can physically change. Name each physical change. Solid turning into a liquid. I guess that needs no explanation. You have ice and you're turning that ice to water. So what's that? Your ice is melting. You have gas and you're turning your gas into a liquid. So you have gas, which are your clouds, and that turns into a liquid rain. What's that? That is condensation happening up there. That's why you get rain. Solid to aqueous, right? You should know that solid to liquid means that you're melting it, but solid to aqueous means that you are dissolving it, right? So that's basically dissolving. Next question states, gases diffuse. Okay, we know what is diffusion. Diffusion is the movement of particles from an area of higher concentration towards an area of lower concentration, right? Describe in terms of particles why gases diffuse. You know solids cannot diffuse, and you know solids cannot diffuse because of a simple reason. Because in solid, the particles are fixed, right? The particles cannot move. That's why solids cannot diffuse. But in gases, you should know that particles can move freely, they can move randomly. That's why they can move from an area of higher concentration to an area of lower concentration. So describe in terms of particles why gases diffuses. We're gonna tell because particles are free to move, right? That's the reason. Because if they're not free to move, they cannot diffuse. Because diffusion is indeed the particle movement. State what determines the relative rate of diffusion of gases at a constant temperature. There are two factors that define the on which the rate of diffusion depends. One is the temperature and the second is the molecular mass of your gas. And they said that the temperature is constant. So the second temperature is going to be your relative molecular mass, right? You know that ammonia gas is going to diffuse slower than or faster than your, if I talk about hydrogen and ammonia, then ammonia is going to diffuse slower. Why? Because it has an MR of 17. The more your MR, the slower your rate of diffusion becomes. Gaseous oxides of nitrogen are atmospheric pollutants. One of the adverse effects of oxides of nitrogen is the formation of acid rain. State two other adverse effects of oxides of nitrogen. Your photochemical smog is one of the worst effects of nitrous oxides, photochemical smog. And how does this photochemical smog form? You should know that your oxides of nitrogen basically react with your unburned hydrocarbons to form a compound. Well, that's A-level content, that's known as pan-oxyacetyl nitrate. Forget it. But just remember that your oxides of nitrogen are going to react with your unburned hydrocarbons to form components of photochemical smog. And the second thing we can write about is the breathing problems that, the oxides of nitrogen are going to cause. So you can say breathing or respiratory problems. Respiratory problems which are going to be caused by your nitrous oxides, right? In catalytic converter, oxides of nitrogen are removed by the reaction with toxic gaseous product of the incomplete combustion of hydrocarbons. You know that your oxides of nitrogen react with your carbon monoxide to form carbon dioxide and nitrogen gas, right? Two non-toxic gases are formed in this reaction, your nitrogen and carbon dioxide. Name the toxic gaseous product of incomplete combustion of the hydrocarbon fuels, carbon monoxide. Right? We know when incomplete combustion happens, we form carbon monoxide or we only form carbon. Name the two non-toxic gases formed in the catalytic converter. You form nitrogen gas, right? And you form carbon dioxide gas. Now, some of you might think carbon dioxide is toxic. No, it's non-toxic. Though it causes global warming, but it does not kill you, right? You're just exhaling it all the time, so it's non-toxic because it doesn't kill you. Iron is extracted from iron ore in a blast furnace. The iron compound in the main ore used in the blast furnace is iron 3 oxide. So they're telling that you use Fe2O3 in the blast furnace. State the name of the main ore used in the blast furnace. That's hematite. This ore is known as hematite. And for aluminum, you should remember that Al2O3 is known as your bauxite ore, right? These names are important. State how the main source of heat is provided in the blast furnace. Combustion of carbon. You know, in the blast furnace, you have carbon. You make it react with oxygen to form carbon dioxide. And this right here is a combustion reaction. And you know, combustion reactions are exothermic. So they produce heat in the blast furnace. So you're going to tell the examiner that combustion of carbon, right? That's all. Name the gaseous reducing agent in the blast furnace. That's carbon monoxide, which is going to react with your iron 3 oxide, right? Your carbon monoxide is going to react with this and it's going to reduce it to iron and form carbon dioxide. So it's carbon monoxide, right? It's a very good reducing agent because it can itself get oxidized to carbon dioxide. That's why it's a good reducing agent, because it's monoxide. It want to become dioxide. It needs to get oxidized, and if it needs to get oxidized, it gotta reduce something, right? And that's why it's a reducing agent. Write the simple equation for the reduction of iron 3 oxide by the gaseous reducing agent in A2. Okay, so we have our hematite. Do we have to write the simple equation? No, we just gotta write the normal equation. Reacting with carbon monoxide to form iron plus carbon dioxide, right? So to balance it out, I'm gonna put a 3 here, a 2 here, and a 3 here so that it gets balanced. The main impurity in iron ore is silicon ivy oxide, which you call commonly as silica or your sand. Write two simple equations to show the role of limestone in removing silicon ivy oxide in the iron ore. So firstly, what happens, your limestone, which is your calcium carbonate, it decomposes to form your calcium oxide plus carbon dioxide, right? It's going to decompose. And the second equation is going to be that this calcium oxide that's formed is going to react with your silicon dioxide to form calcium silicate, which is CaSi, calcium plus CiSiO3, right? Table 2.1 shows 4 different isotopes of iron, A, B, C, and D. Explain why A, B, C, D are isotopes of iron. Because they have the same number of protons but different number of neutrons. You're going to tell they all have same number of protons, which I guess in case of iron it's 26. You can check from the periodic table, which is 26. Just check it from the periodic table, but have different proton or different neutron numbers, right? So that's the difference in isotopes. We're going to check the proton number for iron, is it 26? Where's iron? Yeah, it's 26. Okay, complete table 2.2. Okay, iron can form two species. We know Fe2 plus and Fe3 plus. We got to complete the table. Protons in both are going to be 26. Proton number does not change because of ions. Neutrons, 54 minus 26 and 58 minus 26. Let's see what we get. So 54 minus 26, we get 28 for this one. And 58 minus 26. 58 minus 26, we get 32. 32 here, right? Now we got to write the electron number. You know Fe2 plus means that it has lost 2 electrons, right? 2 plus means lost 2 electrons. And if it's lost 2 electrons, that means the electrons are going to be 2 less than the protons. So protons are 26. 26 minus 2 got to give you 24. So you have 24 here. And over here it's a 3 plus. That means it has lost 3 electrons. So out of 26, you minus 3 and you get 23. So 23 electrons. Describe a test for aqueous Fe2 plus ions. You can write sodium hydroxide test, right? You gotta take NaOH, aqueous, and what are you gonna form? Green precipitates, insoluble in excess, that turn dark brown on standing. Why does this happen? Because your iron 2 plus gets oxidized to form your iron 3 plus, right? That's the equation that's happening over here. Dark brown on standing. So that's the test to know if it's iron 2 plus, right? An oxidizing agent converts Fe2 plus to Fe3 plus. Just find the term oxidizing agent. So we're gonna tell a substance that itself reduces, and what is reduction? Or gains electrons to oxidize an other substance, right? Because we know that an oxidizing agent itself is going to reduce, and a reducing agent itself is going to oxidize. So that's why. Explain why the conversion of Fe2 plus to Fe3 plus ions is described as oxidation. Because Fe2 plus loses an electron, right, to form Fe3 plus. So there's a loss of electron over here. The oxidizing agent in the conversion of this to this ions is aqueous potassium manganate. I state one condition needed for the oxidation to take place. Okay, so you should remember that we use acidified KMnO4. This word is very important, that we use acidified KMnO4, acidified aqueous. So the condition is going to be you need H plus ions because you need acidified. So you're going to write hydrogen ions, or you're going to write protons or H plus, whatever. Iodide ions reduce Fe3 plus to Fe2 plus, okay, in aqueous solution. Suggest the identity of the other product formed in this reaction, iodine, or you can tell iodine. Why? Because look, what's happening is Fe3 plus is going into Fe2 plus. So basically, what does this Fe3 plus do to go into Fe2 plus? It gains 1 electron. And from where does it gain that 1 electron? From iodide ions. Iodide ion is going to give this electron to Fe3 plus and itself form I2, right? So that's the reaction, right? So that's where this Fe3 plus gets its electron from an iodide ion. Okay, a student prepares a sample of insoluble salt, barium sulfate. The student adds aqueous sodium sulfate to aqueous barium chloride. The student carries out the following steps: dissolving 0.1 moles of solid BaCl2 in 100 cm cube of distilled water in a beaker to form BaCl2, then adds aqueous solution which contains 0.1 moles of Na2SO4 to the beaker containing this. Stir the mixture, filter, dry the solid residue, complete the simple equation for the reaction. Include the state symbols. Whenever we form a precipitate, that's always solid. So we're going to write solid. And the other solid that we're going to form is going to be aqueous. And what's going to be the salt? Barium is gone, sulfate is gone. So we're going to form sodium chloride. So we're going to form 2 moles of NaCl, right? Calculate the mass of solid BaCl2 dissolved in step 1. So to calculate out the mass of BaCl2, dissolve 0.1 mole of BaCl2 into this much of distilled water, right? So the mass, to calculate the mass, first we got to calculate out the moles. And how do we calculate out the moles? 0.100, which is the moles. Okay, it's already given to us. So how do we calculate the mass? Mass equals to moles multiplied by the MR. Moles are 0.111, 0.100 MR of barium chloride. Okay, let's go to the product table, figure it out. The MR of BaCl2, here we got barium. Here we got our chlorine, 35.5 times 2 plus 137. 137 plus 71. 137 plus 71. And this gives me 20H. So we get 208 times 0.100, 20.8. So we have 20.8 grams. The concentration of sodium sulfate in step 2 is this. Calculate the volume of 1.25 mole per dm cube Na2SO4 added in step 2, which contains these many moles. So it's good that volume equals to moles upon your concentration, right? Moles are 0.100, concentration is 1.25. Let's see, what do we get? 0.100 divided by 1.25. This is in dm cube, multiplied by 1000 we need in cm cube, and that gives me 80 cm cube, right? State the color of the solid formed in step 2. Okay, so step 2, add aqueous solution of this to the beaker containing this from step 1, stir the mixture and then filter it. So the solid we're forming is simple. What kind of solid are we forming? We're forming precipitates, right, of barium sulfate. So barium sulfate, group 2 salt. So it's going to be white in color. So white color. Right, the mixture is filtered in step 3. State the general term given to a solid left on the filter paper after filtration, that's a residue, and the liquid that's obtained after filtration, that's your filter funnel. The residue that's left on it is called residue, and the mixture that's below it is called your filter rate, right? Good to go. The actual mass of dry barium sulfate, okay, dry barium sulfate collected in step 4 is greater than the expected mass. Why? Because of the impurities on it. This is because the student should do an additional step between 3 and 4. Look over here. At step 3, he just gets the mixture, filters it, and then dry. He should have washed it. Washing is missing over here. Washing the residue. Why? Because there is going to be some soluble salt, because there was some soluble salt in it as well. So there's going to be some NaCl on the barium sulfate, the soluble salt, and that's going to make it impure. So he forgot to wash it. Suggest what the student do in this additional step and explain why the actual mass collected is greater than the expected mass. So we're going to tell that student should wash the residue with distilled water to get rid of any soluble impurities on the residue. That's going to be the first thing we're going to be telling, and the second thing we're going to be telling it that why the actual mass collected is greater. We're going to tell why the actual mass is greater than the expected mass. Mass is greater because of the mass of your soluble impurities, right? Like NaCl, right? Which are going to be on the top of your barium sulfate. State the name of this method of salt preparation. You call this a precipitation method, right? That was simple. You just make a precipitate, filter, wash it, dry it. State the name of a different barium salt that can be used instead of barium chloride. You just gotta remember that whenever you're making insoluble salt through the method of precipitation, you gotta use two soluble salts, right? You gotta use two soluble salts to make an insoluble salt. So over here, we're gonna use any barium soluble salt. So we're gonna use barium nitrate, sulfate salt that can be used in place of Na2SO4. So sulfate salt, we can use what kind of sulfate can we use? We can use sodium sulfate, you can use potassium sulfate, K2SO4. It's soluble as well. Barium salt that can be made by this. I should state the name of a different barium salt that can be made by this method. Okay, so we can prepare a different barium salt. We can prepare barium chloride, right? Because barium chloride is also going to be an insoluble salt. Lead chloride, barium chloride, barium chloride is going to be soluble. That's why we've taken it. So which barium salt is insoluble? State the name of a different barium salt that can be made by this method. So barium salt that's going to be insoluble: barium nitrate, barium sulfate, barium hydroxide, right? Barium hydroxide. So barium nitrate and NaOH going to form barium hydroxide is highly soluble. So barium carbonate, it's going to be barium carbonate. So we're going to take barium nitrate and we're going to take sodium carbonate, right? And we're going to form barium carbonate. Took me a while to realize that all carbonates are insoluble. Done? Okay. Nitric acid, HNO3, and sulfuric acid, H2SO4, are strong acids. Ethanoic acid is a weak acid because it partially dissociates. 1 mole of each acid is added separately to 1000 cm cube of distilled water, 1 dm cube you can consider it to be, to form a dilute solution. All 3 acids dissociate in distilled water. State the formula of the common cation produced when each of the 3 acids dissociate, an H plus ion. Explain in terms of dissociation why nitric acid is a strong acid. It dissociates fully, right? And ethanoic acid is a weak acid. We're going to tell it partially dissociates, meaning all of it is not going to give you the H plus ions. State which of the 3 dilute acids will have the highest pH. Obviously sulfuric acid, because it gives 2 protons, right? HNO3 only gives 1 protons, 1 H plus ion per mole, but 1 mole of H2SO4 is going to give 2 moles of H plus ions because of this 2 here. So we're going to say H2SO4. State the color of thymophthalene in all 3 dilute acids. So thymophthalene is colorless in acids, right? And blue in alkali, so it's going to be colorless. Give the formula of the anion formed when sulfuric acid dissociates in water. Sulfate ion, because it's sulfuric acid. Ethanoic acid dissociates in water, CH3COO negative, because the H plus is going to go, and this is going to be the ethanoate part that's going to be left. So that's the formula of an ethanoate ion. That is initially with the H plus ion, but the S plus dissociates, so you're only left with your ethanoate. Okay. Name the two gaseous products formed during the electrolysis of dilute sulfuric acid using inert electrodes. Hydrogen and oxygen. Why? Because when you're doing electrolysis of sulfuric acid, these are the two ions that you have in sulfuric acid and these are the two ions you have in water. You know that out of these two ions, hydrogen ion is going to discharge, right? And over here hydroxide is going to discharge. So for the dissociation of hydrogen, you're going to form hydrogen gas, and for hydroxide you're going to form oxygen gas. Name the salt formed when calcium reacts with ethanoic acid. Calcium ethanoate. What's difficult? And if they ask for the formula, you're going to tell CH3COO 2 times Ca. Easy. Why is this the formula? Because look, this entire thing, look, I'm going to explain it because sometimes people struggle with it. It's fine. CH3COOH, right? This hydrogen, has a +1. So this hydrogen is balancing this entire thing. So this entire thing that's being balanced should have a -1 on it. So when this hydrogen goes away and a calcium comes which has a 2+, the calcium has a 2+, this ethanoate part has a -1, so you're going to require 2 ethanoates to balance out your 2+ charge on your calcium, right? Aluminum nitrate is made when dilute nitric acid reacts with aluminum hydroxide. Aluminum hydroxide acts as a base. Define the term base. Base is anything that can neutralize an acid, but a base, the new definition is, a base is a proton acceptor. So we're going to tell a base is a proton acceptor. And acids are proton donors. LOH3 is not an alkali because it's not soluble. Soluble bases are alkali state. What this tells you about the solubility of this? It's insoluble, right? Name the other compound which forms aluminum nitrate when added to name one other compound which forms aluminum nitrate when added to dilute nitric acid. If we add aluminum oxide, is going to be definitely going to be insoluble. If we add aluminum oxide, right, it's going to be insoluble, but it should form aluminum nitrate, so aluminum oxide, because aluminum oxide is an amphoteric oxide, and when amphoteric oxide is going to react with, it's insoluble in water, but it's going to react with acids, it's going to react with nitric acid, it's going to form aluminum nitrate, right? The oxidation number of O in this is -2. The formula for the aluminum ion is this. Determine the oxidation number of N atoms in this thing. Show your working, okay? So we're going to write Al is 3+. That means NO3 3 times. This entire thing has a -1, right? Because if 3 of them are required, 3 plus balances, 3 of them balances 3 plus, then 1 should have a -1, because -1, -1, -1 is going to make a -3, and -3 is required to balance a +3. So NO3 has a -1 charge in total, right? So 3 is for oxygen times -2 for one oxygen gives me -6. +5, -6 is going to give me a -1. So +5 is going to be the charge on this nitrate, right? I hope that makes sense. I tried to make maximum sense out of it, because only this thing, a +5 and a -6, can give you a -1. So the oxidation is going to be +5 on nitrogen. This question is about the homologous series of alkanes. 3 general characteristics of alkanes are: they're generally unreactive because they do not have a functional group. That's correct. They show trends in their physical properties such as melting and boiling points. Yeah, they increase down the group. They have similar chemical properties. Yeah. Describe 2 other general characteristics of a homologous series. So we're going to tell that they have the same general formula, and we're going to tell each successive member differs by 1 methyl unit. Okay, each successive member differs by, we've just learned these things, differs by 1 methyl unit, and these are the general properties of any homologous series you take. State the trend in the boiling points of alkanes as the carbon chain length increases. So we're going to tell the boiling point also increases because the van der Waals increases because the number of electrons are increasing, right? Name one other physical property of alkanes that shows a trend other than melting points and boiling points. Describe this trend as the carbon chain length increases. So volatility. Volatility decreases as the chain length increases. The ability to evaporate, they become thicker and thicker and denser. State why alkanes are described as saturated, because they have carbon single bonds, right? Single bonds, right? Propane has the structural formula of this. When propane undergoes monosubstitution reaction with chlorine at room temperature, two organic products are formed. What's going to be HCl? State one condition needed for the substitution reaction to take place. You need ultraviolet light. Why ultraviolet light? Because this provides the activation energy for this reaction to start. And why do we need activation energy? Because we need to break the chlorine-chlorine bond to start this reaction. Give the structural formula and the state the name of the organic product formed. Structural formula of product 1. Okay, so when propane undergoes monosubstitution reaction, two organic products are formed. Okay, so we have propane, which is this, right? I'm just drawing right now, I'm not drawing the answer. And you make it react with chlorine, right? Monosubstitution. That means one chlorine can come here, right? That's an organic product. So that's going to be, we have to give the structural formula, right? So if this forms, right, this is an organic product, right? The structural formula, because you can simply say the chlorine just came in position of carbon, came to attach with the first carbon. So this is going to be 1 chloropropane because the chlorine is on carbon 1, and the structural formula is going to be CH3, CH2, CH2, Cl, right? And then there can be another possibility. You can also form 2 chloropropane, right? How can you form 2 chloropropane? What if because you have to do monosubstitution, that means you just have to replace one hydrogen. So what if your chlorine comes on the second carbon, right? So this is going to have the structural formula CH3, CH, Cl, CH3, right? Two product forms are structural isomers of each other. Define the term structural isomers. You can see 1 chloropropane and 2 chloropropane have the same molecular formula but different structures. This structure has a chlorine or carbon 2, and this structure basically has a chlorine or carbon 1. So they're structural isomers. So we're going to tell the examiner the structural isomers have the same molecular formula, which in this case is C3H345 in Cl, right? Same molecular formula but different structural formula, right? Compound E is shown in figure 6.1 as an ester. So we have an ester bond here. On figure 6.1, draw a circle around all the atoms which make up the ester linkage. So you should know that an ester bond, this is an ester linkage, right? This one, we have to make up the circle of all the atoms that make an ester linkage. So I think we should include a carbon in it as well, because the ester bond is C double bond O, O and C. Something like this. We need a carbon here as well. So if there's a hydrogen here, this is not going to be an ester bond. So I personally think that you should circle a carbon here as well. This carbon should also be included, right? Name compound E. E has three groups in the carboxylic path, so that's going to be a propanoate, and 2 for the alcohol, so that's going to be ethyl propanoate, right? Deduce the empirical formula of compound E. 3,4,5 C5H10O2. Empirical formula is going to be See, this is going to be same as the empirical formula, right? Because we cannot cut it further. You can count the number of atoms. I just know the general formula for esters, that's why I wrote it. Compound E is produced when two different compounds react together in the presence of a catalyst. Name the two compounds that react together to produce compound E. Ethanol and propanoic acid. Simple. We take ethanol, we take propanoic acid, and we form this ester. That's the ethanol part, that's the propanoic acid part. What's difficult? Suggest a suitable catalyst, H2SO4. We use sulfuric acid as catalyst. Determine the number of unbranched ester which have the molecular formula C5H10O2. Okay, so now we have to determine the number of unbranched esters. So the first ester we can make is what they've told us, right? I'm not drawing the hydrogens, that's going to be a waste of time, but see, you have 3 carbons in the acid and 2 carbons in the alcohol. The second ester you can make, you can just reduce the number of carbon atoms in the acid and increase the number of carbon atoms in the alcohol. So you can add 3 carbons here, right? And then you can just take 1 carbon over here and add 4 carbons to your alcohol. This is going to be your ethyl propanoate, the first one. The second one is going to be your ethyl this is your ethyl propanoate. This one's going to be your propyl ethanoate, because you have 3 carbons here, and this one's going to be your butyl methanoate. And then we're going to make our 1, 2, 3, 4, and this, which is going to be our methyl butanoate. I don't think there's any more we can make as unbranched. Then we have to add a branch. So there are 4 which I could make. So I'm going to write 4. All unbranched esters with the molecular formula this combust completely to form carbon dioxide and water. Write the symbol equation for the complete combustion. So C5H10O2 plus oxygen giving me carbon dioxide plus water. I have 5 carbons, gonna put a 5 here. I have 10 hydrogens, gonna put a 5 here. Over here I've got 10 plus 5, 15 oxygens. On this side I already have 2. So 15 minus 2 is going to give me a 13. So I have to add 13 upon 2 here. I cannot do this. So I have to multiply the entire equation by 2. A 2 here. 5 2 times 10. So a 10 here and a 10 with water. Right? I'm balanced, I think. Okay. So I guess we're done with the paper, and that's all for today.